Hi, I'm Mr. Omingyo. So the topic that we are covering today is heating graph. So we're going to investigate how the temperature of a substance will change as we heat it up from solid state all the way to gaseous state. So the example that we are using is water. So imagine now we have an ice cube that is at 20 degrees Celsius and we are heating up with a heat source. So what is going to happen to this ice cube at minus 20 degrees Celsius? Some students will tell me that the ice cube will melt. But as we think back, does ice melt at minus 20 degrees Celsius? The answer is no, because ice only melts at 0 degrees Celsius. So what's going to happen now is that the ice is going to draw energy, heat energy, from the heat source to increase its temperature up to 0 degrees Celsius before it can undergo melting. So on the temperature time graph, we start at minus 20 degrees Celsius. So the temperature is going to rise up to 0 degrees Celsius. So now, at 0 degrees Celsius, we expect the ice cube to melt. Okay, so as it's melting, it will undergo a state change from solid to liquid. So now let's recap. The molecular arrangements for solid, liquid and gas are shown here. So we know that the molecules are arranged very closely packed in solid, and for liquid, right, is like slightly further apart. So in order for the state to change from solid to liquid, we have to break the intermolecular force so that the molecules can go further apart. So in this case, the energy is being drawn from the heat source to break the intermolecular force. Okay, so since the energy is being drawn in to break this intermolecular force, the energy will not be used to change the temperature. So this is very important as it explains why the temperature stays constant during the state change. Okay, so as we draw the heating graph, we expect the temperature to stay constant at 0 degrees Celsius all the way until the ice has fully melted. So just water. So the next step is that the water is going to be heated up. So again, the water is going to draw in the energy to increase its temperature. So we'll just see the water getting hotter. So on the temperature time graph, we expect the temperature to rise all the way up to 100 degrees Celsius before it undergoes the next change. So at 100 degrees Celsius, the water will undergo boiling to become steam. So to change from liquid to gas, again we have to break the intermolecular force. So that means energy is being drawn in again to break the intermolecular force and so we are expected to see the temperature remaining constant. So the last part of the graph, it should be constant temperature. So this is how a heating graph will look like. Temperature rise, the temperature stay constant because of state change, and then temperature rise and then undergo another state change with the temperature being constant.